Good morning, everyone. I consider it as my honor, more than a pleasure, to welcome you all to the inauguration of today's workshop under Institution Innovation Council (IIC) in association with Department of Computer Science. I take it as my privilege to have the opportunity of welcoming our chief guest for today, Mr. Dikshit Rajkumar, Senior Software Engineer, Unicode, Bangalore. It's a pleasure to have you amongst us. I welcome you, sir. I would like to offer a pleasant welcome to our guest for today, Mr. Ashay Bibi, co-founder, UX designer, Pulse Technology Private Limited, Bangalore, and Mr. Dikshit Dennis, software engineer, ITROT, Bangalore. I welcome you, sir. I extend a hearty welcome to Institution Innovation Council convener, Dr. Ramakrishna N. Hegde, the president of today's function, who has never failed to provide his immense, much-needed support to any step taken towards progress. I cordially welcome you, sir. I bid a wholehearted welcome to Professor Ravi Shankar K., Head of the Department of Computer Science and Engineering, who has always been our source of inspiration and guidance. I welcome you, sir. I am delighted to welcome Department IAC convener, Professor Karishma, for coordinating to organize this workshop. Welcome you, ma'am. I would like to offer a pleasant welcome to all HODs and professors of various departments. Last but not the least, I also welcome faculty members, staff and students for gracing this occasion with your wonderful presence. A warm welcome to one and all. Thank you.
Thank you, sir. Marking the words of Booker Washington, nothing ever comes to one that is worth having except as a result of hard work. I now call upon Shivani to give a brief introduction about the resource persons.
Good morning, everyone. I, Shivani, Department of Computer Science and Engineering, cordially welcome the resource person, Mr. Dikshit Rajkumar, working as a senior software engineer at Unicode, Mangalore. Mr. Ashay Bibi, co-founder, UX designer, Pulse Technology Private Limited, Mangalore. Mr. Dikshit NS, working as a firmware engineer at ITROT Inc., Bengaluru. We all welcome you, sir.
I now call upon Dr. Ramakrishna Hegde to florally welcome Dikshit Rajkumar. I now call upon Dr. proceed further to florally welcome the resource person. I now call upon Professor Rakesh Sharma to florally welcome the resource person. You cannot discover new oceans unless you have the courage to lose sight of the shore. I now request Mr. Dikshit Rajkumar to speak a few words.
Yeah. So good morning everyone. So before I begin, I would like to thank the college as well as Ravi Shankar sir for this warm welcome and also giving us the opportunity to allow us to conduct this workshop in this college. So a big thank you to you sir. And also thank you to you students for even attending this workshop. So when I entered this college and when I stepped foot in the seminar hall, it almost felt nostalgic because it's been almost 5 years since I have stepped in this college or in this seminar hall, and I still have those memories of entering this seminar hall almost 5 years ago. So my last memory would be of our department farewell day, where I still remember that I was sitting somewhere over there, and it still brings me hits those the memories still hit me hard. So I think even Ashay and Dikshit also are very excited to conduct this workshop because it is one day when we can give back to this college for being part of this college in the last 4 years, so being part of 4 years. So we are very excited for this. Yeah. So I've worked as a senior software engineer. So I've been a software engineer for the last 5 years, and in my 5 years of being a software engineer, there are many interviews that we have conducted for these freshers, and one of the key things that we had noticed was that there was a lot of gap between the students. Okay, that is what the students had as part of their knowledge as well as part of what the industry expects in terms of skills. Okay. So this gap is mainly because the education is something that you acquire, the knowledge that you acquire, and the industry standards or the industry expects some knowledge that is very required. Okay, there was a lot of gap that we saw in this region. So that is one of the main reasons why we are conducting this workshop, where we educate you and guide you basically on all the technologies that are currently trending in the market, as well as guiding you on how to create those opportunities in order for you all to get your dream job. Okay, so hope this workshop will be helpful for you all and you all make much use of this in your future. Yeah, that's it. Thank you.
Thank you, sir. A teacher does not replicate his image in the student, but molds the student into a person who can build his own image. I now request Professor Ravi Shankar, HOD, Department of Computer Science and Engineering, to address the gathering.
Good morning everyone. The dignitaries of the days and of days, my dear students. At the outset, I welcome all the freshers to Department of Computer Science. This being your first program in the Department of Computer Science. Hope you are going to explore whatever I explored in 15 plus years in this college as a faculty in the subsequent 3 years. Involved in the department activities such as this and explore the opportunities avenues ahead. I would like to actually appreciate and thank my proud alumni, Dikshit Rajkumar, Dikshit MS and Ashay for volunteering this workshop as such. This is the first, actually the collaboration is the first program. Hope it's going to continue. We have many more in the subsequent days. Already they have agreed to have a 2 days workshop for final year students. And, I would like to express my gratitude to Dr. Convener of IIC, for giving this opportunity. Thank you everyone. Hope this workshop is going to be fruitful for everyone. Thank you everyone.
Thank you, sir. Learning is not attained by chance. It must be sought for this order and attended with diligence. Change is the end result of all
good morning. The resource persons, Mr. Dixit, former engineer, Mr. Ashok, co-founder, UX designer, Mr. Dixit Rajkumar, senior software engineer, Innovate, Bangalore, and the proud alumni of Senior Institute of Technology, head of the Department of Computer Science and Engineering, Professor Ravi Shankar, the coordinators of IIC, departmental coordinators, faculty members, and my dear students. Suppose this is the first time the institution's Innovation Council is planning to conduct such workshops as well as brainstorming sessions at the department level. Ultimately, the aim is to bridge the gap as the resource person, Mr. Dixit was rightly pointing out. Many times we hear when we go for, say, US meeting, we interact with the industrial experts there. Most of them, they speak about the gap which is existing between industry and academia. But when we ask for them, kind of help to bridge this gap, they are of course showing a kind of cold shoulder. But unlike that, I'm very happy to note that the persons who are involved in this software industry, they are looking forward. They have, of course, realized the gap which is existing between academia and industry, and as an attempt to bridge this gap, they have come here to enlighten you with the topic Innovate to Elevate. So this is the basic, actually the institution's Innovation Council may be aware that it is working under MIC and MOE, the Ministry of Education, the Government of India, and it is a compulsion for all the HCIs, higher education institutions across India, and most probably our resource persons and all the resource persons are new to this. IIC was established 2 years back in Senior Institute of Technology, and it is doing very good job. And within the second year, we could get 3-star rating from the Ministry of Education, and we are aiming higher. And to aim or to get or to reach our goal, we have, of course, scheduled a lot of such events and given responsibility not only to the individuals or individual faculty members who have got expertise in the field, but also to the department. And in this regard, the department association has a lot more responsibility. And in the coming days, such activities, because ultimately, when you say bridging the gap, the NEP is there already, the new education policy, and of course, it is mainly focusing on bridging the gap. Let me just again glance at the syllabus, maybe 21 scheme or 22 scheme. You will find a lot of changes there, and more focus is on to get the hands-on experience, practical knowledge and exposure. And as a result, the policy shift clearly says that the student should at least spend 1 semester of time in industry. So this will, of course, to maximum extent, fill the gap between the academia and industry. So that doesn't mean that the academic activities should be ignored here. So academics is very, very essential. They are the basics, and innovation, especially for the engineering students, is part and parcel of their life. Innovation, if you want to elevate, you have to innovate, right? If you want to survive in the market, you have to innovate. You have to think out of the box, right? You have to have a lot of creativity in your mind. You have to have kind of collaboration, right? Within your, say, team, and it is not only one department, computer science and engineering. Now it is multidisciplinary. You have to collaborate with the other departments also, because ultimately nowadays you can see whenever a product is emerging in the market, it is the effort of different branches of engineering, not only the computer science. The computer science and engineering is giving the value addition, right? The basic physics of anything is mechanical and allied branches. So it is essential. It is essential. The software side is very much essential to make life simpler and to contribute a lot to the society in the coming day. And this is a kind of cycle. See, cyclic process, I would like to say. Innovate to elevate, and at the same time, at times you have to elevate to innovate, right? So innovate to elevate. So maybe it could be now, right now, during your say college days, you have to have a lot of inspiration, motivation. You have to get self-motivated. You have to have clear thinking and thinking out of the box, and that makes way for innovation. Right. When you innovate with ideas, it will ultimately end up with a product, maybe service-oriented or ultimately a physical product itself. Right. So this type of innovation is essential, and the Institution's Innovation Council is giving a very good platform in the institution. You know, system of technology. You may not be aware of it in the coming days. You will be exposed to many activities, not only activities. Remember, we have an incubation center, right? A startup policy. The management is supporting the students with say latest or innovative ideas to start their own here in the campus with initial seed money, and the right person to contact here is Dr. Surya Krishna, who is taking care of the EDP cell, which is part of the IIC. So the next cycling process, elevate to innovate. Right. So when you of course move on, so you are supposed to elevate all the times. So the best way to elevate yourself is to innovate. So when you are in a working atmosphere, you are coming in contact with a lot of challenges. So there is a scope, or a lot of scope there, who is really innovating to elevate himself, right? So it is a cyclic process, and I'd like to thank the resource persons, our own crowd, alumni, who will connect you much better when they speak during this one-day workshop. And any doubts you have regarding the working style of industry, regarding the gap in supporting, so please feel free to communicate with them. This is one of the most important tool, communication, right? Communicate with them, and I'm very sure they are here to answer to all your queries. And I would like to thank all the three resource persons for coming here and doing the service for the alma mater. It's really a proud moment for the National Institute of Technology as well as the Department of Computer Science and Engineering. Right. And also I would like to thank Professor Ravi Shankar for organizing this workshop and the team. Thank you all.
Thank you, sir. Roy T. Bennett said, great things happen to those who don't stop believing, trying, learning and being grateful. I now call upon Professor Harishma to deliver the vote of thanks.
A very good morning to one and all. Joy is the simplest form of gratitude. It is my immense pleasure to have the task of delivering vote of thanks on this occasion of one-day workshop on Innovate to Innovate, Docker'S Future Unleashed. Firstly, I would like to acknowledge our gratitude to our chief guest, Mr. Dikshit Rajkumar, Senior Software Engineer, Unicorn, Bangalore. Thank you, sir. We also have with us Mr. Ashay gentlemen, thank you one and all.
Thank you, ma'am. Thank you, everyone. I request the coordinators to escort the dignitaries.
Good morning, everyone. Why does everyone look dull today? Weekend mode? Waiting for Sunday? Okay. So I've been a software engineer for the last 5 years. Okay? So there's one thing common that all software developers do. You know what is that? So when suppose we build something. So we are software engineers, right? So we build something. So there's one thing we do after building. You know what is that? Any idea? Good, yeah. Testing. Testing is something that we do. So I'm a software engineer. So I expect this session not to be an interactive session. Okay? So I expect answers from you guys. It doesn't have to be right. Wrong answers are also expected. There is no wrong answer basically. Okay? So any answer you get might be right. It's of some form of error. So I expect some answers or at least hands being raised. Okay? So let's do one testing round since you're software developers. I'm going to a software developer. Let's see if you guys can reply. Because you know, every workshop or any not interview or session that we do, there are always different kinds of people there. Some people who know the answer but keep going. Then there are some people who softly say the answer, or they tell their friend, tell this. Okay? So there are different kinds of people. So let's see, so everyone is an individual, right? So everybody has the ability to speak, everybody has the ability to raise their hand. So let's do a test. Okay? So give me one word where all of you can shout out, one word. Any word. This was three first. Should I pick someone? Tell me a word. Okay, I'll start with this one. First girl over here. Just any word where everybody can shout out. Can be anything. Anything in the world. Random. So what do you eat in the morning? If you're shy to tell even that, then either your mom's cooking is that bad or... Huh? Okay. Come on, be a little louder. See, this is the first example of students I say, who know the answer but they keep quiet. Come on, this is the mic, right? Okay, fine, she's nervous, okay, give you some time. Okay, so let's all shout Dosa. Okay, ready? And on the count of three. So, 1, 2, 3. Okay, good start. Yeah, maybe only one dosa. Okay? So next thing is let's test our arms. So whoever has a right arm, please raise your hands. Okay, everybody has, right? Okay. Good, okay, good. So people can speak, people can raise their hands. So we can start off our presentation. Okay. Okay, so software engineering, okay. So you are just second year students, right? So you are eventually planning to be a software developer, is it? So either you will be going through development or you will be going to a tester, basically. So what is your perception of what a software developer is? So you only have in mind, right? Suppose me. So when I was in second year, when I thought software development, people going joining IT companies, I thought people are just coding and coding and coding, going home. Next day they come back to office and again they code. And what movies they shoot, they just press certain buttons and everything happens. Things get hacked and so and so. So what is your perception of what a software developer is? Or what do you think a software developer can do? Can anyone answer? I mean, it can be anything. I mean, what is your perception? It doesn't have to be right. Yeah, just think, like what do you think the software developers do on their daily basis? Like what is their task? Does somebody want to give an answer? Like, just come on, just speak up, no problem. Even if it's wrong, it's no problem. If you feel that they just go there, have coffee and come back, that is also fine. Anything is fine. No one? One person more enough. You don't have to be shy. Nobody's going to judge you. Lecturers are here, but still they won't judge you. You're scared to answer. Or shy to answer. Okay, at least in groups you'll answer. Somewhere, okay, I won't look. You'll just answer. That is also, okay. So basically in software engineering, okay, so we have a common perception. So what we learn from our labs, we assume that whatever coding we do there, that is what we have to do in a software industry. That is, we'll be given a question, you have to find the output, and that's it. That's the end of software engineering. But no, but in software engineering, there are a lot of aspects, okay. So there is designing, there is, testing is one of the aspects. Then deciding what kind of infrastructure you have to use, what kind of code you have to write, what are the different data structures that you have to use in order to get the best outcome. So there are a lot of aspects. So all these aspects collectively make you a good software engineer. So software developer is not just coding. So there are a lot of aspects. So all these aspects you'll get to know once you enter the industry. Okay? And it also depends on what type of company you choose. So if you choose a company where your job is a very minute thing, then you will probably have this one aspect of this software development. But if you join a startup or you join a company which is very small, so So since they have to build an entire product, so what happens is you learn the entire cycle of what happens, like how are user requirements taken, gathered, and how are they used, how do you convert them into use cases, how do you convert them into designs, how do you convert designs into code, and how do you convert code into basically products. So there are a lot of aspects which you have to learn, and all these things collectively make you a good software engineer. So nobody wants to become a software engineer. The goal is to be a good software engineer. Okay. So one of the things in software engineering is that people tell you from childhood, hey, you will study till 10th. After 10th, your life is safe, secure. Once you go to PU, then they say, okay, hey, study till PU. After that, everything is set. Then once you go to engineering, you get to know that oh shit, you have to get a job. So in engineering, what is your goal? Getting a job. But getting a job is not the only thing. So getting a job is actually the easiest thing over here in software industry. Getting a job is simple. Anybody can get a job. There are people working in software industries who have background from mechanical as well as backgrounds from electrical or electronics. I've seen people who are performing much well than people who have CS backgrounds. Okay? So y'all know this, right? Like y'all, how many internals do you, how many exams do you all have? In one semester, let's say. Huh? 2 internals. Okay, 2 internals? 3 internals, right? 2. Okay, revised, okay. Things have changed. Okay. So 2 internals and then 1 external. Okay, so that's in 1 sem. Okay, so how many students over here, I don't know, I think girls won't be included. How many students over here are studying on the last day of the or previous day of the exam? Can you raise your hands? Okay, now we see. Teachers are not looking. Who studies on the previous day of the exam? I mean, it's actually a proud moment. I was one of them. Sorry to say. So I see many hands. Boys? How come the boys are shy? There are too many girls nervous. Okay. So okay, assume that you studied on the previous day of the exam. So let's say you have 2 internals and I think each internal is of 3 days. Yeah, okay. So let's say 3 days, so 2 internals, only 6 days. Then let's say 1 external. External how many subjects? 6 subjects, 6 days. So 8 days. No, let's exclude the holidays. 8 subjects? Okay, 8 days. So 8 days plus 6 days, how much? How much? Okay, so 14 days. So it requires just 14 days to pass an entire semester. Okay, let's assume an entire engineering. How long does it take engineering? Okay, 4 years. So out of 4 years, let's say you study on the previous day, you clear engineering, you get a job. So how many days will it take? 15 into 4, so almost 2 months. So you see, you spend 4 years in your engineering, but you just take just 2 months or whatever, 2 months to just get a job, to land a job. So that's why it's easy for any other stream. So what they do is, after they finish engineering, they take some course, they finish it in 2 months, they end up getting the same job what we do 4 years to study. So you see the difference over there, 4 years and this is 2 months. So what do you do in 4 years? There are other people who are doing 2 months. Because it is easy. There's nothing difficult in learning code, there's nothing difficult to get your first job. Okay. So what is the difference between that 2 months gap and 4 months gap? Like what is the difference between you and a mechanical student now? What do you have that the mechanical students don't have? Yeah, that program. Not programming skills. Let's say in this aspect, let's say what do you have more than what a normal student has of any other background? So both of you have the same job. Both of you have the same team, same company. Both of you are getting the same pay. But you do 4 years, you do 2 years, 2 months to get the same. And of course, you will learn going forward. Both of you will start from the same place because you still have to study the domain knowledge, how the company functions. Both of you start from zero again once you get the job. So what do you have that the mechanical student doesn't have before?
You're a computer engineer. He's a mechanical engineer.
Not exactly. Okay, fine. I'll give the answer. The answer is time. Okay, so you have time to learn something that you already learned in computer science in the last 4 years. But they don't have. They start directly after the engineering. Okay, so that is the difference. That's why we say that gap is there. Because you all what you do is you all just study and you'll get a job. They finish their course of mechanical, then they study for 2 months and they get a job. So what you all have to do is you all have to apply whatever you are studying by doing something extra in the time that you have, or these 4 years you have. So letting you all have 3 years remaining. So just, why don't you just go and look out for something, or like search what is actually happening in the industry, and what are the different tools used, what is coming up. So currently what happens is, where has the technology reached? Okay, so back when I was in 2018 when I passed out, and it's almost been 5 years, right? So what happens is, so in 2019, AI and data science, everything was fairly new. And now you see how much has it changed from 2019 to 2023. Lot of difference, right? Now it's so easy there are so many companies that are adopting AI, ML and all that stuff in 2023. But you see the students who are graduating in 2023, they're still the same as what the student was when graduating in 2019. Okay, see how much has changed in the industry side and how much has remained still in the education side. So there's always a thing that you do is you need to upskill yourself whenever you get a chance. Okay, so upskilling is something that is very important in software engineering. So even if you get a job in a very good company, imagine. So getting a job is not enough. So after you get a job, you have to continue to maintain, to upskill yourself. Now you say, okay, I get a job, I want Python job, I get a Python job, I sit over there and I learn Python for 10 years. So when you're trying to shift, when you go to the next another company, they ask you, hey, what have you learned? You say, I'm an expert in Python. But he says, but what's the use? We don't work in Python over here. We work in a different language. We work in Java. So if you stay constant, like, okay, I'm only Python developer, I'm going to learn only Python, you are never going to make it in your industry. So there's always a change that you have to upskill yourself no matter what, whenever you get a chance. If you want to have a good job or you want to stay in the software industry, you have to make a point of upskilling yourself or learning something. It can be anything. Either knowing technology, what is happening, just finding out, using technology, that is more than enough. So, clear, right? Okay, so let's say, so the first thing is gaining experience. So how do you gain this extra skills apart from what your academic skills? The first thing is your skill training should start with formal training. The skill training should start. Basically, once you come to college, after 4:30 when you leave, it should not end over there. Okay, I learned, now it's time to enjoy or play something or do whatever you want. Okay, then you should start working, checking out. You can see even tutorials on YouTube. A lot of things are there. You can just explore what is happening in the industry. So increasing hands-on experience. So this is one more important topic. So I see a lot of people do a lot of certifications, like minute things, minute certifications. But what they do is once they do the certification, they forget about it. They don't even use that. They answer some 4 or 5 MCQ questions. The application says, congratulations, you are certified as this developer or that developer, and done. People forget. The next one they show in the interview that, okay, see, I have the certification, but you have not done anything on it. It's basically of no use. Okay? In most of the companies. Like, I can't say all the companies, but most of the companies. So you have to increase your hands-on experience. Okay, you have to try to work on it, try to build something. Doesn't matter if it's a hit or if it's a flop. As long as you work from it, you learn from it. And learning is one of the most important things that what even IT companies look for. How much you have learned, not how much you know. Or how much you can do. Increase then one is volunteer work, personal projects. Yes, you can also. So in engineering, the only time that people do a project, from what I've seen, including me, I'm not. When we do projects only when it is required. I think 5th sem we have a graphical project, and 6th sem we have, and final year we have a final year project. And it's only time we try to move away from academics and do something or create something out of the syllabus basically. So we need to try to increase that. And personal projects, then volunteer work. So there are a lot of places or like online classrooms where you can share your knowledge. Suppose you have learned something. There are certain companies which expect certain teachers or like people who educate someone who are below you. So how I am educating you or advising you? Same way you can advise someone who is just entering engineering. Then if you have the capability, you can also advise them and probably direct them to the right path. So there is nothing like, okay, I'm a software engineer, I don't know anything, or that that person might know more. It's never left. Okay. The next thing is other practical work and objects. So whenever you get an opportunity where you know you can learn something, just take it. Because opportunities do not come directly to you, you have to create them. Okay. Next, the last thing is participating in hackathons and bootcamps. So have you heard about hackathons? Okay, so hackathons also is where they code and so they got a problem. The main part of hackathon is not solving the problem. Okay, the thing is, suppose you're going, if you don't know coding, just attend it. So at least you know what are the problems others are facing, what are the actual problems the world is facing. Then probably you can even think about it in your while you're in school, and then you can probably build something. You're finding a project based on that. Okay. So the next thing is getting certified. So this is also something where I already mentioned that there are a lot of places where you can even learn. Like there is Udemy, there is Udacity, there is LinkedIn Learning, there is AWS certification. There are a lot of certification. So as long as you do it and apply it wherever you can, then there is a lot of scope for you in the IT industry. The last thing is building your portfolio. So portfolio, you all know what a portfolio is. In simple terms, it's just a description about yourself, okay? In a professional manner. Not I'm hyped so much, so not those kind of information, but more about the work that you do or about you, your skills and lot of that is your portfolio. So just like your resume that you have, but portfolio is also something like that. So there are different platforms where you can build interactive portfolios or offline portfolios. There are a lot of platforms, so you can use that. Then you can also create personal websites. So a lot of people do this. They learn how to build websites and they create a website of their own with their domain name, where ABC. If it is Sachin, then Sachin.com or whatever. So you can even showcase that in your portfolios. Yeah, showcase is the next thing. That is where you just show your work that you do. It can be anything small or big, as long as you feel that okay, it is something relevant and it is something that the industry is looking for, or it's something that the industry is looking to solve. Then that is really a good option. Then code samples. So how many of you over here use Stack Overflow? Anyone use to find the answer? I mean, you all have some questions, but maybe not code related. Any other questions? Stack Overflow, Quora, they answer a lot of questions, right? Has anyone answered any question or asked any question?
Just checking the solutions.
Yeah, but everyone just checks the solution and nobody contributes to it. It's an open source, anybody can contribute to it. So suppose, just go through it. If you see that okay, there's any question that you already come back, don't copy the answer or put in ChatGPT, that's not allowed. But if you feel that you can answer something or in terms of code, like if somebody has a question, hey, how to print this, if you know it, just answer it over there. Because that is also helpful over here in your career. The number of contributions that you give to your project or to the public. Next thing is your technology stack. So this is something that is very important and you have to constantly update with the demand that is happening in the IT industry. The next thing is your resume basically about yourself. So blogs and articles. So there are a lot of places or websites where you can even add your own blog. It can be about anything. It's better if you, I mean, in this context, it's always better to have an IT related blog. If you learned something or you found out something new, you can just blog it out. Social media links. Social media links, what are social media links? Not on Instagram and all that stuff. So this is basically all your professional one. There is your LinkedIn. How many of you are on LinkedIn? How many of you have seen LinkedIn? How many of you know what LinkedIn is? Okay, sir. How many of you don't know what LinkedIn is? I saw some people didn't raise their hands for anything. Okay, so LinkedIn is a platform, okay, so where you can basically look out for jobs and basically it's a professional kind of a platform. So you can also check it out, create LinkedIn profiles, create GitHub profiles. How many of you know GitLab, everything? The repositories we store code, nobody's okay. Just check that out, GitLab. So those are basically social media links. Suppose you created a project. So you create a project in your system, so nobody else can see it. So if you can host this, if you host the code or move the code open source to any place, then that will be helpful. Then the last part is always you have to keep it updated. That is the main thing. Yeah, so that's pretty much it of of how is it in the life of a software engineer. Okay, so the next session will be done by Dixit NS on how to land in a software job. So over to you.
Yeah. What I wanted to talk, I think most of the things he already told. So I'll just keep it simple. So what I wanted to say, like apart from skills, what do you do in academia? Like how important the marks are. Okay. Everybody here will think like, oh, I have that skill, I have this skill. I didn't need marks. Average I don't need. I'll get a job. No, it doesn't work that way. So what I'm telling you should know that when a recruiter comes, he'll expect they'll put a cutoff. Do you know why they put a cutoff like you need 65%, you need 70% average? Do you know why? Anyone? It's not that it tells them that you remember everything that you did in 4 years of engineering. It's not that. It is it tells the recruiter that if you take an example, it's like 70%. It'll tell them that you have come to college every day, you have put some work on your subject, and you have gained some knowledge, and you have put that effort into your papers, and you have got marks. Okay, that tells that recruiter can trust you. You know, it can trust you to do the job every day, so that his whatever responsibility he has, he can transfer it to you. So the thing is so now Ravi Shankar sir, everyone they used to tell this to us when we were in college, when we were studying, but we used to ignore them. So he said we were the last day learners. I was not the last day learner. I was last hour learner. Okay, I was my and my friends both another. There was a friend called Karthik. You might know. We used to learn 2 hours before the exam, not previously. So, but when we came to the final year, you are in second year, right? So it's important to know this, because when we came to final year, they told 70 cutoff. Oh, we don't have the cutoff. What do we do? We have less opportunities. So if you have less marks, you'll have less opportunities. He said you can end up in a job, but you will not get a good job. So if you want a good job, you also have to have good marks. It's not difficult to get good marks in engineering. You have to study say he said previously. No, if you study previous week, if you keep 1 week for one subject, right, you'll get distinction. It's not that difficult in engineering. Yeah. Yeah. Building up and what you will do first in resume, first thing what a recruiter will see is your marks, and next what he'll see your projects. So what you have to do in whatever Dixit said, 4 years of computer science engineering, what you can do is you can get good marks, good projects, whatever project. Every semester you will have some few subjects where you can combine those subjects and build a project. You can do a project. So if you go to 5th semester and all, if you have DBM, database management system, it will come to you next. I think it's 5th semester. Using that, once you're done with DBMS, you can do good web applications, all those things. So if you do 2-3 applications, from that point onward, 5th, 6th, 7th, so you'll have good resume. You can you can put it on your resume. You can have so when the recruiter comes, oh, you have done this much good projects. He'll be impressed. Okay. I'm preparing a portfolio already. This has talked about it. Getting a job. So SIT. So here, what happens? You think Amazon. If you are here, you want to get job in Amazon, Google, all those big companies. How can you get a good job in those big companies? So is it possible? Yes, even if you are in SIT, it is possible. But how do you get that job? So you have to prepare for that from second year onwards. If you want to when you reach at final year, right? Then you want to get job from on these companies, then it's not possible. But if you prepare it from like second year onwards, it's very much possible. So how do you get the opportunities? So what happens? These big companies, they recruit students from colleges. Okay. So but end up what happens when they like around June, July, those students will join to the company. But most of them won't join to that company. Like once they'll have like 3-4 offers. So what they'll do, they'll join only one company. The rest of the two, they'll not join. So what company will have requirement. So during these time, right, these companies will put this thing, job posting for freshers on LinkedIn. So you have to seize this opportunity. So if everyone can apply, but not everyone can get the job. So you have to, if you prepare it from like second year, right, you can end up this job, like then other skills you have to Dikshit already told. So I'll tell what is the importance of data structures and algorithm and problem solving. So first thing, what these big companies they do is like they'll have this problem, they'll test your problem solving skills. So how do you gain this problem solving skills? So you'll study data structures and algorithms. Which semester they'll study this? This semester, okay? Yeah. This semester you study this data structures and algorithms.
Algorithms in course.
Okay, it is separate.
Yeah, it is changed.
Yeah. So this is very much important. You have to really study this, and you have to apply this to solve problems. So where do you solve problems? Like, you have this. Have you heard of lead code or hacker rank? All those things. Have you heard of this? No. These are the places where you get problems. Then you can try to solve this. But you have to learn. What you have to learn? You have to learn this DSA, then a programming language. As sir already told, you know Python, I guess now. But you also have to have another language that you should know. Like they'll study Java. They'll study Java. Yeah. So you make. So what do you do with so you know Python? What do you do with knowing Python? You don't know, right? Yeah, you don't know. So yeah, you have to apply this data structures knowledge and programming skills to solve problems. So it's just you think like okay, last 1 year you will solve these problems, you will practice, but it's not enough. Why it is not enough? Everybody will do this for when the companies come, they'll start studying algorithms. They'll study programming language, they'll practice. But you have to be better than them. So to be better than them, you have to start doing everything from maybe next semester or this year. So you have to practice a lot of coding and problem solving skill to get a good job. Okay? Thank you.
Thank you, So they were more into become a software engineer and a software developer, all these things. See, very dull faces, I don't even, I'm scared now, standing here looking at your faces. More women entrepreneurs, right? Women entrepreneurs than men entrepreneurs. I see around 10, 15, than around 50 odd women. Yeah, that's good. Computer science having more women is good for the boys. Even we were less in our class, so but the options were very less. Okay, so I'm here to tell how to become an entrepreneur. How many of you are learning? Oh, nice. We have one. At least one is raising. Anyone else? Girls who's doing mehendi or anything else? YouTube, Instagram ads, anything. Anyone who's earning? Let it be 1,000 rupees a month or even 100, 200 rupees. Anything. Who's earning? Girls, women traders, future. Please. No one. Only one. What are you doing?
I do
Marketing? Marketing? Instagram marketing. So you have good followers?
just started.
Okay. How big is your team? 6 people. That's great, man. You're doing wonders. Great. Yeah, for you. Namit from Bangalore. Okay, Namit from Kerala, big round of applause for him because he really did so much. He had never thought of these things because I remember me, Dikshit, sitting over there. Even we were like you, not even we were afraid to raise our hands. We were even planning to at least bunk the class and come to one of the seminar. So I was that student. Someone here. And that's okay, that's fine because even I was the same guy. So they told there's a seminar happening here. There's some entrepreneur coming here, telling how to become an entrepreneur. I was sitting there and okay, I was listening. I was the only guy from my class. No, they were. So they were telling like how to become. I was just sitting there listening. Okay. He was just bragging about himself. I don't know who was the person. He was telling you have to do money, that money, this money, this money. The money hasn't still come for me, but so that's not about it. It's not about money. Keep the money part aside. You work on it. You still have and you're doing one without it. So what I want you guys to just understand, just keep the software engineering aside. Just make yourself free and let's see what happens there. So first is building the skill set and knowledge. As he told, you can't straight away start a job. If you want to do that, just leave engineering and start. People tell that, let's say, some CEOs, they left their college and started with entrepreneurship. I didn't go to college, but now I'm learning intros. Don't keep all those things in your mind. That never works. And probably not in India. That never works here. Don't be in that mentality also. First thing all of you have to do is get into a job, work for 2 years, understand the IT. How does that work? How does an IT work? If you don't understand that, you cannot do anything. You have to go there, land in the job. Understand how that company works, how its functionalities. You leave that company, how that process works. You go to another company, how that works. After that is done, then you can come up with an idea. Okay, then I can come out of this and start something. Okay. So building a skill set, it can be anything. We told Python, learn Python. Learn Python, get good thorough with it. It takes around 1 year or 2 years to get thorough. I'm not telling you to become a great coder and then come into this entrepreneurship. Just learn a little bit and then come into it with your own idea. Research and identify opportunities and market research. What I can tell you guys as of now is one thing which I did later on once I came out of my engineering. I took a book and I started writing my ideas. Whatever the idea is. It might be very silly also, don't even laugh about it. Just take a book, write, make a heading that this is the idea, this is the name of this. So I'm going to do this. This is the very best stage for you guys now. Because you have, 5 more cents, to work on that idea. And as you told this, I can see what some funding given. Yeah.
The workshops or activities related to
Okay. So what you can do, just write down the ideas and
this is self-funded from the fund.
okay. And keep yourself ready. Like you don't know what your ideas will come out because if you write down ideas, there are a lot of ideas which I see open TV and Sony Live. Someone is coming there and pitching that idea in Shark Tank. I can okay, this is the idea I am speaking out and it's already out. So there's nothing new you're going to build. Everything in this world, whatever is there, it's not new. It's already done by someone else who has put that thought in their brain somewhere in this world. So don't think that this is my idea, this is the first time I'm doing it. No, it's already done by someone. So just take a book, write down. It will be helpful. Don't think about, who's sitting next to you. They will not, put food on your plate tomorrow. You're the one who's going to put food on your plate tomorrow. Okay, your friends will come with you like these two. They'll come to my, they'll come with me. But end of the day, I'm going to my house, they're going to their house. Okay? I have to earn for my own company. So that's why there's co-founders. You guys guys, this is the first thing. Write your ideas. You have 5 more cents. List it out. Once you come out, then you can give your gradual thought on each and every plan. It might be old by that time, but you'll have better, more understanding on your projects. Building network. This is very important. Okay? If you are an introvert person, this never works out because this is what I was. I was very shy taking my engineering days. So as I got into engineering, the first thing I was like, all new people. So the college where I studied was, I knew most of them. My high school, everyone was same. So I was shy. So when I came here, the first thing I was like, everyone is new. Let me be extrovert. So who has to tell what? So you guys also, it's okay to tell wrong answer. Just lift your hands and tell if it's a wrong answer. Nothing. Nobody's gonna laugh. Even your name, who's next to you doesn't know anything about you, and he's still dumb and things like that, and just raise your hands and just answer it out. Yeah. So building network is very important. You need to go and talk. Our friend Amit, if he has seen this, he has gone and spoken to many of people, and they have told him you have to do like this. Am I right? Or else he wouldn't have got this idea because being at this time you're earning good. Just taking okay. So if you guys want party,
Point number 2, in our campus, we have a research lab.
okay.
Actually, in the library, so students can collaborate any discipline.
Yeah, what you can do is, make a team of like 2, 3 or 4 members, come up with an idea after your college or something, go to the research lab, sit like 1 hour is enough in a day and plan like we are going to do this and this. Gradually start, building it. If it's from your same class, what I can tell is by the time you reach your 6th, 7th sem, the projects will start, the final year projects. Start taking up that one. So once you're done with your, everything, you'll have a phase like 2 years, 2 sems to work on that. Once that is done, if the lecturers are convinced that this is a good project, let's say there will be a lot of competition like case,
KCST, water,
you get some funding around. So once I come to that, so once that is done, then you'll have a exact grip on your project. Then you can go and pitch it outside with investors. That's really helpful for you guys. I want a lot of female friends of mine to start this because male they will anyhow do this, but women it's very rare. When I see a women coming up with I have a lot of friends who I'm starting this. I really appreciate it because it's being in India it really looks great. In next coming 5-10 years, India will grow like hell. You guys no need of going outside and searching for a job. They'll just be here. By the time you graduate, you'll have a lot of jobs and you're in the correct stream, that's computer science. So by the time next in 26, 27, you guys will be in the basis people, even with the knowledge or anything. So just stay here and work on. And the government is giving a lot of support for you guys. A lot. So you just need to find the exact spot where to hit what. That's it. And develop a business idea and so the idea has this is very needed because you come up with an idea and result is like this is not working out. So this happens a lot because this happened because we come up with an idea, we work for a year and end of the day it doesn't work. So that puts us to the ground level. So that hurts a lot. But you have to be ready for anything in entrepreneurship. It's not like how you do computer science. This is totally different. You'll have to do coding, you'll have to do HR, you'll have to do all the things. If you have your own office, you have to sweep also. You have to wash your everything you have to do there. So it's enjoying always. So first, recently create a business plan. What I would say at this moment is, I think you guys have a good mentor as of now, with Namit. You ask him, I want to start so and so, where should I start? In terms of online business, he might help you. If you want to do offline, you can get back to any of the mentors here or me. We will guide you where to start. Designing the business, This might take a lot of time because once you get a good project idea, then you have to start designing the business. You have to start with branding. You have to list out what is needed. You have to, you have to be a financial person. You have to get into marketing. You have to negotiate each and everything with the industry aspects. So these things will take a lot of time. Not something you can do hands-on with your college. But these are the next steps which when you come out of the college you can do. Because unless you speak to someone with industry expert, you have no idea what's going on outside. You will feel like you are still a kid. So you will feel what am I doing? But be open, just ask questions. Even when I was going into some startup funding initially, the two startups that I worked, I didn't join into MNCs directly. So I just wanted to work on this startups. So I joined two startups. So both gave good opportunities where I had to go to the field and work, where I had to do marketing, branding, development, everything comes in. So here you are just thinking on software development, but there you have to do MCA, MBA, all these things at one stretch you have to do. So it's hectic, but this life, it's totally different than software engineers. Every day morning you wake up with so much energy that I want to do something. So yeah. The legal structure is not required as of now because you have to register your company. It takes, I might need another session to talk about. Yeah, secure funding. If you do anything also, end of the day you need money. This is what everyone struggles, what we also struggle. We need money. You can put your savings into that, but for how long? Got it? So finding programs or company qualifies. So government is the first thing that gives. I guess the current government is giving, or the previous one also was giving a good funding. So the two startups that I worked also had one around pretty good amount to run the startup for at least 2-3 years. So that's enough. If you can run a startup with the funding for 2 years, then you guys are doing good. Okay, so you have to make use of this. If you have any doubts on this grants or funding, you guys can drop me a text anytime. Crowdfunding sites and Kickstarters. Crowdfunding, there are websites where you'll have to put your project ideas, and the investors from that, they'll come back to you and you're ready to invest on you, where you have to give them the exact proposition of their ideas and the market research, all those things. Then they'll fund all your project. Yeah, pitch your business to angel investors. Angel investors, how many of you watch Shark Tank? Come on, raise hands, please. Good. The next time I come, most of you it's not like you're giving promotion to Sony Live or something. But I want you to guys to watch that bundle and something. They tell you 1 crore rupees, they are raising 1 crore rupees for 100 crore values. What is it? They talk a lot of business terms there. Sometimes even we are like, we don't know because I'm not from an MBA background. So you need all these small things to understand. So I would recommend most of you to watch even the US Shark Tank also. Anything is fine. But just watch it, just for fun of it's fine. Just watch it. It will be helpful somewhere or other. You get to know a lot of business ideas which are running, in Karnataka. You'll see very young people who's 14, 15 coming up with ideas and raising fund of 1 crore rupees. So we feel ashamed that I'm just 25, 26 and I'm running that. Get a micro loan. Obviously loans, banks give loans. It's not the huge thing, but you need to work on that. If your idea is good, then anyone will give anything. If your idea is good, even I will invest on your company. You can just text. I don't have money as well. It's lower a way to success. Anything to ask. And by the way, there's a test making under where you need to score about 60. So that counts for your E-certificate and probably assessments of other assessments. I don't know how many of you are worried about that. I shouldn't have told this service. They'll be put down.
Let them be attentive, listen to the presentation.
Yeah, that's it. So we'll start with Docker now. So we'll start with some executions. After that, we'll move on to the lab where we'll see how to execute Docker. Any questions there or anything? Just random. Anyone can ask. Anything? Guys? Save the mail. Namit, you want to ask anything? Funding or anything? You're doing great, mate. No one? Okay, fine. We are always here. Don't feel shy. Like you can come and ask us later. We are there to be here.
Grants not go Indian government side?
No, no. Just a I wanted to restart. If you have any doubt, you can, maybe here or me. If you shy or anything, you can just, one by one come and ask. It's okay. I mean, it's okay to ask questions.
So in lab session, maybe they'll interact.
Yeah, we interact. I mean, nobody's going to tell anything to any of us. We were the same kids like you.
After the presentation, we'll have a lab session. So during the lab session, people can interact with the resources.
Okay, we'll catch back on this entrepreneurship in next, probably after 2 years. By that time, I want, more hands to raise, more different careers, get their own ideas. Just ideas are done. Then we'll sit and talk, we'll discuss what to do next. We'll try to get investors for you. Don't just settle in life for a, easier job and move on. This happens with everyone. I shouldn't tell you, but when I came here in this college, there were only 4 to 5 members who attended the entrepreneurship session. But now it's coming back to the same college and talking about entrepreneurship. It feels proud. It might feel the same thing for you guys also. So take this opportunity really good. We never know because tomorrow you might be the next superstar in Bangalore. Just give your best, that's it. Over to Dikshit Rajkumar. Any questions, just tell us. Don't feel more. Docker is really good.
Just a few minutes in this regard. So I think 2 important points is what Ashish said. One is to document your ideas. So any idea that you have, whether it's small or big, it doesn't matter. Just write it down because somewhere in the future you might meet some person who would say, hey, I have this idea, and you might have it in common, and both of you can collaborate and make an idea actually work. So always document it, and maybe in the future it will be helpful. So I know there was a lot of talking going on as of now. So sure some people might have got over-motivated. They ever get over-motivated? Like, oh my god, studies are not important, syllabus is not important, let me just go and tear my books and then focus on other things for IT ones. That's a wrong thing, okay? So studies should come first. Okay? So one of the things that we learned in our engineering is that, or when you come to industry, that coding, actually typing code is actually a very small part, right? It's a very small part of the IT industry. So all the subjects that we learn, like data structures, then let's say software engineering subject, it's all theory. We always should assume that those subjects are the most boring subjects and that are not something useful for us. So we should always ignore that and we should always focus on coding and getting the output in the lab. But once we enter the industry, we realize that those subjects are actually the most important ones and coding was actually a very small part, and we had to just code a very small piece of code, and that's what. So studies is actually important, and what you learn in your syllabus is actually important. So don't ignore that. So today I'll be giving a workshop on something called as Docker. Okay. So Docker is one of the platforms that is currently being used by most of the IT industry, and it's become like a standard now. To start your development, whether it's in your computer lab or whether it's in your company that you work or at your home, Docker has now become a standard, and it has made life a lot easier. Okay. So how many of you have heard of Docker? Has anybody heard Docker? No one? So for today's agenda, so first we'll be going over the areas in software development, followed by we'll see what are virtual machines. Once we see what are virtual machines, we'll understand what is Docker, we'll understand Docker, then what is the Docker, how is it different from a virtual machine, what are the different Docker components that we have, what are Docker files, what are the advantages of Docker. Then we'll be running few commands in Docker to see how you bring it up and how does it work. And in the end we'll have a Q&A session. Okay. So first thing is areas in software development. Okay. So the first step in software development, the first three steps, there are three main steps in software development. First is develop, second is distribute, and execute. So what these three things mean? So develop is nothing but you're building something. Suppose you're building an application or you're building some software or whatever, writing code. That stage is called as the development stage, where you all basically write code, you all tell what are the different packages required to run that code, what are the different dependencies that you have, and a lot of things. So that is nothing but the development part. Second is the distribute. So whatever code you write, so now suppose you're working in a company, the company cannot use your laptop and run code because the code has to be running somewhere, right? It has to run on a server 24 hours. You cannot have your website running in your local system and when the system shuts down, everything goes off. Okay, so that doesn't work, right? So we need to move our code from our local system or from your laptops to a particular environment or production environment where we can run this code or run this application 24 hours. So the process of moving this code from your system to the production servers or your Google servers or any server to run this is called as distribute. And third one is the execute. So execute is nothing but the code actually running in production with all the specifications that you have provided in your development. So you say in your development in Python. So even in your production environment, you need to have Python over there, otherwise it will not run. Okay. So in software, so when you work in a software company, there are four stages, okay, when you build an application, 4 stages. So the first is local. Local is nothing but the system or your system where you execute your code or you build your code. Second is called a test environment. So there are 4 environments, not stages, there are 4 environments. Your local environment. Second is your test environment. So whatever code you write, we transfer that to a test server where we are testing whatever code that you have been writing, okay, and whether it's working fine or not. So once we check that everything is working fine, we move to something called as a pre-deployment stage. Okay, so what is also called a staging environment. So a staging environment is nothing but the exact copy of your production environment. So where your actual code has to run for the clients or for anyone visible to see. So the staging environment is also where we test the code to see that whether the user will face any difficulties and what changes you make. So, but it is not exactly 100% accurate as the production environment in terms of data, like whatever data, credentials and all that. So all that cannot be there in your staging environment of the clients because that's very confidential, right? So it will have very some basic information, but it will not have all the information. Okay. Then the final stage is nothing but the production stage where we actually run the code and we actually see certain websites or whatever, any software application that you run. That is the actual production environment. So we have 4 environments. So what is to happen is, so when we deploy this, so what happens, we start from local and there are 4 steps to production. So when we used to move this app code from your system till the production environment, what used to happen was there were a lot of challenges that we used to face. Okay, so let me give you a simple real life example. So you all are familiar. So your ancestors will have some dish, right? Some family recipe. How many of you, anyone has any family recipe that's been in long for a very long time? At least 4 generations. Anyone, any recipe? No? Okay, let's assume there is a recipe, okay, that is given by a great grandmother. Okay. The same recipe is passed on to your grandmother. Okay. Now she tells you, like when she has prepared the recipe for the first time, she makes it using some ingredients, some vessels, or something she has used. And she tells the next person that, hey, I want to make this dish to your grandmother. So your grandmother, what she does? She also tries to take the same, what we say, not the maybe some difference will be there in the amount of ingredients that she takes or the vessels that she uses. So you see the difference. So do you think that will both your grandmother and your great grandmother's food have the same taste? No, right? There will be some difference. So when you move it to another environment, again coming to the staging environment, so when you move it again to your mother, again the recipe changes. So it can have either something has changed within the recipe, like you have added a different quantity basically, or the quality of the ingredients that you use changes. So there are a lot of changes that affect the outcome, that is the taste of the dish. Okay, so similar thing is to happen in our programs or in our development. So when we used to write it in local, in our systems, we used to install certain packages. So we install, okay, this is required by this package, Python is required, Python version 3.8 is required, Python version 3.10 is required. So you all install your own versions and then you should pass it on to the next stage, that is your test stage. And if some miscommunication happened, what happens is the developer of the test stage would install a different version of Python. So what would end up happening is you would face some errors which are not expected when you execute your code in your local system. So these problems were happening. Okay? So there was no single environment where you could confidently say that, code that is running 100% correct in your system will run 100% right in the production system. So to tackle these problems, the concept of virtual machine came up. So have you ever heard of virtual machines? Never heard of virtual machine. Okay, so virtual machine is so virtualization. The concept of virtualization is the method of running a virtual version of a computer resource on the cloud. Okay, let's take a virtual machine. Nobody has installed virtual machine on their systems. Suppose you have a Windows system and you want to use Ubuntu. How either you dual boot it or you can run a virtual system on your computer. So I don't know if anyone has done it. So what this virtual system is? So virtual system is an isolated computing environment that allows developers to use an OS via the physical machine. Okay, so if you see, so suppose you have a system and you want to run a virtual machine. So it is a machine on top of a machine, inside a machine. Okay, it's an isolated machine inside a machine. So whatever changes you do in your actual machine do not affect the change, do not affect the virtual machine. So that was the concept. So what their plan was, okay, we create a virtual machine. Suppose we move this virtual machine to another environment, it should basically work the same because your local changes do not get affected. Or whatever things you do, your personal work that you do not get affect the virtual machine environment. So if you see the virtual machine, so this is the architecture of a virtual machine. So at the bottom, you can see something called as an infrastructure. So infrastructure is nothing but your hardware that you have in your computer. And above the infrastructure, there is nothing but the operating system, where your kernel lies. And above the operating system is a hypervisor. So hypervisor is an engine for virtual machine, which basically manages the connections and it talks to the hardware and the virtual machine application. And above this, above the hypervisor is nothing but your individual virtual machines over there. So we have created 3 virtual machines over here. So each virtual machine can have its own operating system. So in your Windows, you can run Linux in the form of a virtual machine. So you see the architecture here. So every virtual machine, you see one difference. It has its own operating system. Every virtual machine has its own operating system, and above the operating system is the application that you are building or you are running. And yeah, so you can see the 3 applications. Next. So even in the virtual machine, the problems that we saw was very bulky inside. It used to consume a lot of space. So we saw that every virtual machine had its own operating system above the actual operating system of your system. So that was consuming a lot of space, and it was taking a lot of, it was consuming a lot of space, so we couldn't build a lot of applications. And it was very difficult to scale your machines. So that is where the concept of Docker is. So Docker is an open source platform that helps a user to package an application and its dependencies into a Docker container for the development and deployment of software. I know it's too much for a definition, but I'll explain it in simple terms once I come to the architecture. So now Docker is a tool that has become a software standard for developing, distributing and deploying applications. So Docker has now become a general practice for every developer to start off with Docker and then build applications using Docker or inside Docker. So the architecture of Docker is almost similar to, because it follows the concept of virtualization. So the architecture is similar. So you see the infrastructure is at the below, which is your hardware, the host operating system, and above that is your Docker engine that manages the requests. And above the Docker engine, now you have your application. So you saw the difference. Can you go next slide? Yeah. So you see the difference you saw in the virtual machine architecture. One of the main things is the virtual machine architecture required an OS of its own. So the OS itself was consuming a lot of space. But in Docker, what they do is they share the operating system of the host. So only your application is something that is running on your inside the container basically. So you saw in virtual system we could have only 3 applications. But same thing in Docker, now we can have around 6 applications running. The same system, assuming they are the same systems. So let's just see what's the difference between that virtual machine and the Docker. I already went over this. Yeah. So the architecture is one of the main things. Okay? So you see, the virtual machine, let's assume that those 3 blocks that you see on top is the entire memory space required by that the system has. So we could do only 3 virtual machines in this entire system. But in Docker, the same thing can now run 6 different applications in an isolated manner. So that was one of the key advantages of Docker. Okay, so the differences for Docker, first thing is in terms of space. So space, you saw that it consumes very less space, but virtual machines, they take a lot of space. Then in terms of performance, so Docker has a more stable performance, and virtual machines, since they consume a lot of resources and a lot of problems, it is very unstable. So in terms of efficiency, Docker is highly efficient, and virtual machines are not that efficient compared to Docker. Then the capabilities is Docker can run on multiple machines. Okay, so once you build Docker application, it can run on any machine. no matter what kind of machine, Ubuntu, Windows, it can run on any machine. But virtual machines, virtual can run only in very limited systems. Then portability. Yeah, so Docker is very easily portable since it is small in size, and the way how you build Docker containers is very simple. So it becomes very easy to move your code that is there in your system to the production environment without any roadblocks. So yeah, VM has that compatibility issue where it has to be the same system. A lot of things have to be kept in mind before you deploy it. Then scaling. So scaling is nothing but how much can you expand? So you saw in virtual machines you could have 3 machines, but in Docker we can have more and more. So it's very easily scalable. Suppose you want to remove a component also, it becomes very easy to remove and add a different component. Boot up time. Yeah. Boot up time is Docker has very short boot up time, and virtual machines, since it has to load an entire operating system, it's like starting a new computer. But Docker, since it uses the existing host, it doesn't have much boot up time. Okay, so the components. So what are the different parts of Docker that we see here? The first thing is, so Docker has a client. It has a host, client and host. It communicates through REST APIs. So we have a client, we have a host, and we have registry. Then one by one I'll go through it. Okay, so you see Docker client. It has the first thing is a Docker client. Second is a Docker daemon. Nothing but the process or the engine that runs. Then there's something called as Docker images. So inside your engine there's something called inmages, and there's something called as containers. And in the end you have something called as registries where you can push your images or whatever code, not code. I'll tell you what images are. So you can push those images to your registry, and anybody can later pull the images, or you can have a private registry. Docker client. So Docker client is a service which uses REST APIs to send commands to the Docker daemon. So that is simple. So command line is nothing but you type commands. So in order to execute your containers or build an image to run Docker commands, you need a client like a terminal or something. So that is nothing but a Docker client. So that uses REST APIs to communicate with your Docker daemon. So Docker daemon is your engine that is basically accepting the commands and processing those commands. So after Docker client we have Docker daemon. So Docker daemon checks the client request and communicates with the Docker component. Simple. It's just the middleman where it does the communication. So whatever instructions you give. Next is the Docker image. So Docker image is a file of instructions which is used to create containers. Okay, I'll go a little specific into what Docker image is. So that's very important. So I told you the problem in terms of that same. I'd like to take that same recipe example. So we saw that as the recipes of things, a lot of things changed. Okay, because there was no proper instructions given on how the food had to be passed on to the next generation. Okay, so in Docker we have something called as an image. Okay, or an image is created by a Docker file. Docker file is nothing but instructions that are given. So you clearly specify certain instructions over there saying that which dependency or which package has to be installed, what is the version of the package, what is the environment it has to run in. So all these instructions are listed in that Docker file. Okay? And since it's only one file, this same file is passed on to all the environments and executed. So when you execute that file, only what is specified in that file gets runs in the container. So the containers that you see, the containers are something that runs your Docker file. So container is nothing but a vessel. Say in terms of a recipe, the container is a vessel. So you tell that all the vessels are the same now. All the vessels are the same. You give the instructions in the form of a list, saying that what it has to be, what are the exact ingredients, what is the exact quality of the ingredients. Everything is the same. Everything is listed in that. And then when you execute that file, it runs inside a container. So there are 4 containers, and you have one Docker file. All the 4 containers, if you run the Docker file for all the 4 containers, it will have the same exact environments over there and all the dependencies. Yeah, and last is nothing but the Docker registry. So a registry is a service used for hosting and distributing Docker images. So let's say the recipe file or the file that you generate and you put instructions in, that can be hosted somewhere on a server. So that is nothing but the Docker hub. So in the hub, there are already people who are contributing and providing their own images. So they are writing some images, they are pushing it, where we can just use their already existing images.
So suppose you want Python in your system. So what you do is there is already an image or a list of options given in the Docker Hub saying that this is the Python image. What we have to do is directly run the command docker pull. You can see the second command there. So once we pull, it pulls it from the registry and brings it in your container. So now we know for sure Python is running in your container. You can also have your personal registries. Okay, so these are public registries. You can also have your personal registries where you can, suppose a company has a registry, you can push images to that registry and then we can use it from that registry. So similar Docker files. So Docker builds images automatically by reading the instructions from a Docker file. So the instructions I told you, right, that the file, that is nothing but it's called a Docker file. The Docker file, which is a text file, and it contains all the commands in order needed to build the given image. So exactly what I explained, that is the Docker file is a file. So once you build that, so when you write the file, you have to only build it. Once you build the file, that will automatically be running inside your container. Okay, so this Docker does not really, Docker is not only used in software technologies. Docker can be used even in your colleges. So I think one of the biggest challenges in colleges is installing a particular version. What you all do is, I think you all go to each computer and then you all install a particular version. Is it how it happens? Suppose you install a new Postgres, you have SQL, right? MySQL. So what you do is they go to each computer and make sure they install. They go to one system, they set, they install, again they go to next system, set and install. So how it helps over here is, so you can create a Docker file of what kind of MySQL you want. And you have to run only one command, that's to build it. Once it's built, all the systems will have the same environment. So you won't get any conflicts, like okay, a different version is used over here. But what usually happens is, suppose you install a software. What happens, it has certain dependencies, okay? It requires some dependent packages. So when you install Python as well, it requires certain packages to be of a specific version. Okay, so suppose you install a new application, the new application also will require those same packages to be of a different version. So what happens generally? If the version required is greater, it usually updates it. And now since you update the previous version, something else breaks in some other place. So that is avoided over here in Docker. So the different advantages of Docker is that Docker, okay, microservice architecture. So there are two types of architecture. One is monolithic, that is basically all your systems, all your dependencies, all your packages are running in a single system. That is called monolithic. But Docker is a microservice architecture. So it's so that different applications, multiple applications could be run, and each application runs only one specific instance. So one app can run only Python, one app can run only Postgres, and one app can run any other service, Redis or whatever service. So it becomes microservices and it becomes easy to manage. And there's less point in failures. So the second thing is infrastructure as code. So I told you now to run or to install certain dependencies like versions and all that stuff. Now you have to write code for it. Code is in the form of a file. So you say that I want this, these are the things or dependencies that I want to install, and you would have to go and tell the version, please install version 12, version 2, because they have some versions as well, 12.A or 12.B and so on. So there are applications like that. So since in a Docker file you exactly specify which version you have installed, so if you just pass on the Docker file, even they install the exact same version. So the infrastructure and what has to be used, what are different services that have to be used are written in terms of code. Next is multi-environment strategy. So we saw that Docker can run on any environment, Mac OS, whether it's Windows or whether it's Linux. Fourth thing is a loosely coupled architecture. So I said that we can split our services into different apps. So each app is running its own service. So since that is possible, not possible in, it's possible in VM as well, but it is like it consumes a lot of space. But in this one, it consumes less space. Fifth one is easy and faster deployment process. So exactly what I told. Suppose you want to install something in another system, it now becomes very simple because you have to run only one command and your file. So it installs everything immediately. Sixth is increased productivity. That is, so now since everything is running in different environments, suppose something breaks in some environment, we can just work on that specific environment And if there are multiple breaks happening in different environments, two developers or two people can work on individual components. So it becomes easier and faster to fix your problem. Next. Yeah, isolated infrastructure, we saw like VM virtualization is always running containers in isolated infrastructure. Eighth is nothing but portability. So we saw like it's very easy to move your applications from local system to the production environment since it's just one file that has to be executed. Yeah, reduced infrastructure cost. So infrastructure cost. So whenever you're using a server, the amount that you pay to use the server depends on how much, what are the things that are running on it, how much memory it is consuming. Okay, so virtual machines, this is how it consumes a lot of memory. So we would eventually end up paying more for it, for the services that we're not using. Okay, so Docker solves that by reducing the infrastructure cost and by limiting the size to making it very basically a small size. 10th is nothing but scalability, because we are able to scale to as many applications as we want. Next is secure. So Docker is very secure. So there are a lot of permissions that you can give in order to prevent any wrong communication happening. And last one is again it's lightweight. It's very lightweight. It doesn't consume a lot of resources. So apart from this, there are a lot of other advantages as well. But it's just a few of them that are listed. So before we move on to the queries, there are certain Docker commands that you will run. You can see how Docker works, how to build Docker files, and we run certain commands. So I can just show you that. Okay, I am able to. So are able to see the screen, right? Okay, so to verify, first command is let's verify if Docker is installed. So to install Docker, just run the command Docker -v. So it says that Docker version 20.10.11 is installed. The first thing that we do is let's pull a simple image. So I told you the registry already has certain images. So let's pull an already existing image. So before that, I can just show you the registry. So Docker Hub is a place where we can when people have contributed and okay, so I don't remember my password, so okay. Okay, so the next thing we'll see how do we download an image. So all the images are already pushed to Docker Hub. So we just pull an image that is already existing in Docker Hub. We can use the command Docker pull. We can say hello world. So hello world is an image that is already present. It basically prints that Docker is running and it's running hello world program. So we need to run the environment first. So what happens is, so first time when you pull the image, suppose what Docker internally does is, it checks in your system if that image has already been installed or not. So if that image, hello world, has been installed in your system, then it pulls that image from your system and then executes it. But if it's not present in your system, it pulls it from the Docker hub, the place where all the images are stored, and then it executes it. So first thing it will be pulling hello world. So hello world is the name of the image. Okay, so it already pulled the image. So let me show the images that we have in our system. So you can just use the command Docker images. So it shows that there are two images over there, hello and hello world. So now if you want to remove an image, if you want to execute an image, so you can use the command Docker run. You see the output generated, hello from Docker. So to execute the command, we can just use Docker run. So once you use Docker run, so there are different images that you can pull and run. So let me try another image with Python. Let me execute it first.
Guys have a book, just write down the scripts of it. We need to execute all these things in the app, so it will be helpful for you guys. Just note down one line like Docker minus v minus version what you have done here. Mobile install. If you have mobile, that's fine. You can take it. Don't upload it anywhere.
Show the command. So to check the version, you have to run Docker -version. To pull an image, it is Docker pull. Don't write each and everything, just write the command for what is the purpose of it, because later you can even search it on Google and find out what it means. So pull is nothing but we get the Docker image from the Docker hub and run it and bring it in a local system. So shall we move to the next one? Okay, so listing all the Docker images and by Docker images. Okay. Docker images. It lists out all the images that we have. Yeah, all the images that are installed in your system. Okay. So you saw. It is executed. So I installed one more image called as Docker pull Alpine latest. So this tag that you give, so anything that you give after this colon is nothing but the version of it. Suppose you want to install so on. Just have to install it and it creates an image. Yeah, so suppose you're using a Windows system or so Docker is basically compatible with only Linux, okay? But now Docker is made compatible with Windows as well as Mac OS. So to make it compatible with Windows and Mac OS, there's something called a Docker client that you have to install. Okay? So that is nothing but it's the same thing, just a GUI that is for Docker. So you can see the images that I installed are present over here. You can ignore this one, so the previous one. So Hello World is something we installed and it's saying it's in use, and Alpine is something that we installed. The next command is to run an image. Okay, so we can run an image using the command docker run. You can pass certain options and the image name. So we'll run the Alpine image. Running an image is nothing but executing into the container. So now what happens is, so when you create the Hello World container, Hello World image, we pulled it. It basically installed that image and started running it in a container. So now we can execute into that container if you want to by doing the command docker run. So we can run the container using docker. Now you can see just the hash is there. So now if you just see that hash over there at the bottom right, that means now we are inside the container. We are not in a local system. So if I do an ls over here, so it's a list of directories. So this is nothing but all the file system that is present only inside Docker. So nothing of your local system files are present over here. Suppose I even create a file over here. Let's say this is a VI editor. I'll just type something and I'll save it. So this file that you create, we do an ls over here. Now we just created only over here. This container. So this is now available only inside the container. It's not available outside. So suppose in so to exit the container or stop running it, you can even first exit this. So you'll come back to your local system. So anything that you want to execute. So now we can create images for anything. Suppose you want to install Python, you can create an image of Python and you can enter the container. The same Python is not installed in your local system. It is only installed in your container. So suppose you want to run a Python script or you want to run Python any command on the terminal or the Python ID, you can run it in Python. You can use this container. So let me just install Python. So that will be more helpful for you. So these tags are actually present in Docker Hub. Okay? So once I'm able to log in, I'll just show you how to get the tags. So I believe this is how we run Python. Okay, so it's checking. I've installed Python 3.10, so now it's pulling it. So it takes some time to download all the packages. So when it's saying pulling, right, it's basically in the Docker Hub, there is that Docker file which has all the instructions and all the dependencies that Python requires in order to run properly. So you can see it's pulling all the required dependencies. So suppose you want to run code in Python 3.8. So you can always create another container but with the tag for Python 3.8. So now you have two instances of Python running in your system. So if you do it in your local system, you can run only one instance. Either you upgrade or downgrade the previous version. But in Docker, you can have two containers and you can have two different versions of Python also running in it. And if you need some package for Python 3.10, you can execute into that container and run and basically install any package only in that container. No other containers are affected. That's why it's called an isolated environment. So first thing we do is pull everything, then we start downloading. So the Python image is created. So now let me run that image. The image is over here. Check on that, it's not installed properly. So I'll move on to the next thing, I'll come back to that. So, next thing is removing an image. So, removing an image, so basically you use the command Docker image. So, to remove an image, you can use the command Docker RFI, so and the image ID. Suppose you want to remove this hello world, you can just whatever code is there, use the partial code. In order to stop, I mean, you see this error over here, right? So you cannot remove an image that is currently being running. Okay? So first you need to stop an image that is currently being running, and only then you can delete it. You can use Docker stop and the for this. So when we use it in Mac, there are certain problems that we are realizing. So I'll just give it 2 minutes. I'll just check it. So currently it is not running in the system. Okay, so we'll be switching the system and we'll be giving you a workflow again in the lab. Okay, so we'll be changing our system to a Linux system and then we'll be running the same commands again. Okay, so could you all kindly move towards the lab? So we'll be doing the same exercise over there as well.
All of you have to go to second floor lab, okay?